Let us put in practice our skills to solve this equation, this logarithmic equation, using not only logarithm properties, but also the skill of factoring quadratic expressions. And I'm going to use the diamond method. So the first thing that I will have to do is to determine the domain of validity. I'm going to introduce that by the expression given that. Now, given that, so I'm going to take every argument inside a logarithm, and they necessarily have to be strictly greater than 0. So I will have those three very easy to solve inequalities, and I'm going to report them on a number line to have a definite interval. So here I would have x greater than negative 1/4. For negative plus 3 greater than 0, let me do that in 2 steps and have negative x greater than negative 3. And I'm going to divide everything by negative 1, which will flip the inequality. So I'll have x less than 3. And finally, 0 divided by 7 is 0, so I will have that. So if I report all those on a number line, so I'll have negative 1/4, 0, and 3, I will have the following. X has to be greater than negative 1/4. It has to be less than 3, and is going to be greater than 0. So if I compute all those three inequalities, it gives me the following interval. So given that x has to belong to the interval 0, 3, this one here. Now, the necessary conditions for that logarithmic equation being set, now I can solve it. And the first thing, so let me label that equation number 1. I'm going to condense this side. The addition is going to become inside the logarithm a multiplication. I will have 4x plus 1 times, the addition becomes a multiplication, negative x plus 3. And this would be equal to ln of 7x. Now that both sides of the equation are enwrapped, so to say, by the logarithm, then they're going to cancel. And I will have 4x plus 1 times negative x plus 3 equals 7x. So I'm going to distribute, I'm going to FOIL this. I will have negative 4x squared, and 12 minus 1 is 11, and 1 times 3 is 3, equals 7x. Now I'm going to, since I'm recognizing a quadratic equation, I'm going to set it to 0. That means I'm going to cross over the 7x, this addition of 7x, onto the other side. And 11x minus 7x is 4x plus 3. Now, personally, to perform the diamond method, to factor this expression, I prefer to have my leading term in as with a positive coefficient. So I'm going to multiply all the equation by -1. So I'll have positive for x squared, negative for x, minus 3 equals 0. Now, here comes the diamond method with a special dedication to Benjamin Lara. All right, so on top, I'm going to put a times b. Remember that I'm working with ax squared plus bx plus c. So I'm going to put on top a times b, 4 times -3, that is -12. At the bottom, I'm going to report b, which is -4. And on top, I'm going to put ax, which means, in that case, 4x. And then I need to find two numbers. They multiply as a times b, and they add up as b. And for that, I would have -6 and +2. See, the -6 times 2 is -12. -6 plus 2 is -4. So let's continue, because something very important is that I need to simplify those fractions. So I will have, for this first fraction, I can divide everything by 2 and have 2x over -3. Here I would have 2x over 1. So the factoring will be as such. Let me clean things up here. I will have 2x minus 3 times 2x plus 1 equals 0. And in case you're not completely sure, you can always double check and FOIL back to see if you have it. So here, 2x times 2x is 4x squared indeed. Then -3 times 2x is -6. 2x times 1 is 2x, and -6 plus 2x is indeed -4x. And finally, -3 times 1 is -3. So do not hesitate to take the time to FOIL it back to see if you did things correctly. So anyway, now that my quadratic equation is factored, I'm going to take each of those factors and set it to 0. And I will have those two very simple linear equations to solve. 2x minus 3 equals 0 if x equals 0 plus 3 divided by 2, which is 1/2. And here I would have 0 minus 1, which is -1, divided by 2. Now, in that particular case, I will have a last step, because as you can see, -1/2 is here, and 3/2 is in the domain 1.5, the domain of validity, which means that this solution that I stumble upon, -1/2, is in fact an extraneous solution. So after determining the domain of validity. After solving the equation, then I've got a third step to conclude that therefore this equation number 1 is such as x equals 3/2, therefore excluding this extraneous solution. And here we go. Good luck.